There's also something else to be aware of when you're collecting data, and that's the environment that you're in. And there's two things to consider. One is attenuation, and that has to do with the atmospheric issues around where you're collecting the data. And there's amplification or reflection. So when we talk about attenuation, what might cause the inverse distance law to not properly apply, meaning doubling the distance reduces the decibels by 6, it may reduce it by more than 6. If the wind speed, wind direction, if there's dust or a lot of debris in the air, if it's raining, misting, or snowing. And the way to think of that is anything that's going to absorb sound or that's going to disrupt the free flow of sound through air is going to cause this attenuation effect. So you'll get even greater reduction in the amount of sound that you can detect at a given distance from a sound source. The other thing is amplifiers. So it can also cause a problem with the inverse distance rule because reflections off of walls, hard surfaces, tunnel rooms, long, narrow, or complex piping, any hard surface where sound can reflect. I was once doing work with a large university up north, and they had a massive network of underground tunnels where steam lines and electrical power cables were running through it. And you had to be really careful about how you were using ultrasound in that environment. It's very easy to hear ultrasound bouncing off of other surfaces. So just something else to be aware of as you're collecting data.